Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Functions, Basics. Concept number 5, inverse function of a one-to-one function. The odds of someone doing exactly what you tell them to do is slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. If I could stick every single Algebra 2 student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose by ordering and purchasing either the complete Algebra 2 cram session or the entire function series, okay? You have lots of classmates, friends, peers, and or colleagues who are taking Algebra 2 alongside you as well. Tell them to inbox me at memedicine@gmail.com so that they too can order the entire Algebra 2 cram session. Let's delve into the concept. And you'll be glad you spread the word because you guys will make great study buddies. Function basics. Is the inverse of a one-to-one function also a one-to-one function? Definitely press pause if you need to, and I'll give you a moment to think. This does require some thinking because the answer, I'm actually giving away the answer. It's not so straightforward. But yeah, press pause if you need to. Okay, so to answer the question, the inverse of a one-to-one function is also a function. But to answer the specific question as to whether or not it's a one-to-one function, it's not necessarily a one-to-one function. Sometimes it is, and sometimes it's not. So it may or may not be a one-to-one function. Okay, but in the event that the inverse function is not a one-to-one function, its domain, or all the x values for which the function is valid, can be restricted or shrank or zoomed into one specific region, okay? And thus, this can make the function one-to-one. So you're probably like, what is she talking about? Let me show you an example. Take, for example, the function y equals the inverse tangent of x, okay? Also called the arctan of x. These names are interchangeable. They're two names for this function. And let's say that we're looking at this function restricted with a restricted range, the range being all the y values for which the function is valid. The restricted range is between pi over 2 and negative pi over 2, okay? Pi over 2 is indicated on the x-axis or the domain area of interest. That's not what we're talking about here. The range are the y values for which the function exists, okay? But here we have the restricted domain of the restricted range rather of the arctan function, okay? Without restricting the range of the arctan function, this is what it actually looks like. And notice that the a in this is capitalized as opposed to lowercase this, because whenever the arctan is led by a lowercase a, that means the range is restricted, or maybe even the domain. But if not, it means that it's the entire function, okay? And so without restricting the range, a vertical line drawn through this function would touch the function or the curve at many places. And we remember the vertical line test is not even a test of one-to-oneness. It's just a test to establish whether or not this is a legit function. And if the vertical line touches it more than one place, it's not a legit function. That's why we have to restrict it, okay? So the arctan relation would return many values, meaning it's a one-to-many relation rather than a one-to-one function. And if it were not restricted, again, we wouldn't even be able to use this as our example. So in graph form, the horizontal line test passing over a curve determines whether or not it's a one-to-one function. And to pass the test, the horizontal line can only intersect the graph at most once. So we see that, yeah, this does pass the horizontal line test. Although these regions right here may look flat, they're not. They're always at an incline. So if this line were infinitesimally small, yeah, it would look like it's only touching at one place, okay? I know this is a little confusing, but just stick with me. I know you can do this. All right, so the inverse function of the restricted arctan function is going to be the tangent of x, okay? And the inverse function of this function can be gotten graphically by basically flipping the arctan or inverse tangent function about the line y equals x, which is depicted right here, okay? So the inverse function of this function is obviously not going to be a one-to-one function because we can see that the horizontal line drawn touches at many places. This is the tan x function, okay? And that's why we basically had the range of the inverse tangent or arctangent function restricted because the domain of the inverse tangent function would also have to be restricted in order for it to be a one-to-one function, okay? And the reason why, again, is because the range that we previously saw for the arctan function becomes the domain of its inverse function, which is the tangent of x function. So let's apply that restriction. And we can see here that it does pass the horizontal line test. Once you flip the arctan about the horizontal line y equals x, the restricted range becomes the restricted domain of the inverse function tan x, and we can see that it passes the horizontal line test and hence is made or forced to be a one-to-one function. Again, the region of the restriction is between negative pi over 2 and pi over 2. This may be a little confusing and advanced, but just bear with me, okay? This is just one tiny concept in Algebra 2, so don't flip out over it. All right? Thanks for tuning in and good luck studying.